Let us discuss a problem of IIT JEE 2010 paper 1. This is based on Doppler effect. This is simple, but it requires good efficiency in calculation. It is given that a stationary source is emitting sound at a fixed frequency f naught, which is reflected by two cars approaching the source. That means there is some source, it is fixed, and two cars are approaching this source from opposite sides. The difference between frequencies of sound reflected from the cars is 1.2% of f naught. That means whatever sound they are receiving and then reflecting, so that reflected sound frequency differs by 1.2% of original frequency f naught. But we have to find what is the difference in speeds of the cars in kilometer per hour. That is important, to nearest interior. That means we have to find difference in the speeds of the car in kilometer per hour and convert it into nearest interior. And it is given that the cars are moving at constant speeds much smaller than speed of sound. So we have to use this fact to make the calculation simpler. And the speed of sound in air is 330. To try and then check the solution. This kind of problem may be repeated. And the solution comes out to be around 7 km per hour. Answer should be 7 km per hour. Let us see how it should be solved. First, imagine one car only. If a car is approaching with velocity Vc towards this fixed source, which is emitting sound of frequency nu naught, and let the nu1 is the frequency received by the car, and nu2 is the frequency of sound reflected by the car. So applying the Doppler's formula, nu1 should be written like this, because here while receiving the sound, the now important point is that while receiving the sound, car behaves like a moving observer, and the effect of velocity of observer comes in the numerator of that popular formula, that is mu naught into v plus v minus v observer upon v plus v minus v source. So sign is taken with common sense, but one should remember that observer effect comes in the numerator, and since it is approaching the source, frequency will increase, so we will use here plus sign. Now this frequency which is received by the car will act as original for this car, and it will reflect some other frequency, say it is nu2. The nu2 will be given as nu1 into this factor. Here this factor is selected assuming that now car is behaving as a source. Because reflecting sound, the car will behave as a source, and denominator its velocity effect will come, and since it is approaching the observer somewhere here, frequency will be, we have to find reflected sound, so frequency will be increased because it is moving towards a reflected sound. So in denominator, velocity of car will be taken with minus sign. Now if we replace this nu1 from this, so nu2 will be equal to nu naught into this expression. Now using the fact that Vc is much smaller than V, and then apply binomial approximation, what we can write, this formula can be converted to this one. This is important. If you take V here outside, we will get V plus Vc by V in numerator, and in outer 1 minus Vc by V, and then use a result that 1 upon 1 minus x is approximately 1 plus x for small x, right? So this formula will come into the picture, and in fact it will come something like 1 plus x squared, then a further approximate is 1 plus 2x, where x is Vc by V. So if we finally obtain this result, this indicates that the reflected sound frequency will be original frequency into 1 plus twice Vc by V. This will be the frequency of sound emitted by one car which has velocity Vc. Right? For other car, suppose which has velocity Vc dash, frequency of reflected sound emitted will be obtained by same formula. But here Vc will be different. Only difference is that, say that frequency is mu2 dash, the mu2 dash will be mu naught into 1 plus 2 Vc dash by V. Now take their difference. While taking difference, we will get this result, right? And this difference is 1.2% of original frequency. Original is say nu naught. Those symbol I have changed here. Here it is given f naught. I have taken nu naught. Doesn't matter. So this will be equated with this one. So from here, delta Vc, this will be delta Vc. Delta Vc will come out as this much. And if we place V in meter per second, we will get difference in velocity in meter per second, but we have to find it in kilometer per hour. Once I also made mistake here, I approximated it 2, but answer is to be in kilometer per hour. So at this stage, multiply 18 by 5, because we know that 1 meter per second is 18 by 5 kilometer per hour. And this one should remember. And this will come out to be approximately 7.13, so it will be approximated to 7 kilometer per hour, right?